Focus and we'll go. So, good news or bad news, however you want to take this, we are finally today starting Algebra 2. Everything I've done to this point in my class, and I'm pretty sure in the other classes as well, have basically been a review of Algebra 1. Today is the first official day of Algebra 2 material. And it's complex numbers. Okay, so we're still dealing with quadratics. I put it off absolutely as long as I could. For those of you that were in my class last semester, I drug this out. Obviously, we're in January. So today's day one. We're going to do 4-4 complex numbers. 4-4 complex numbers. And the first thing you need to, vocabulary-wise, and some of the vocabulary probably might not make sense to you just in the words. It'll make more sense when I start putting it into practice. But we have within the complex numbers what we call the imaginary root. Imaginary root. And the imaginary root is defined as I squared equals -1. Now, I don't expect you to remember that. That's not what's important. What basically I need you to get from this is that if you have a problem in a quadratic equation and you've solved it and you get an answer that looks like this under the radical, okay, -9, when you go to simplify this, okay, like yesterday, we broke it apart, and this is actually the same thing as -9 times -1. The square root of 9 is 3. The square root of -1 is I. Okay, is I. So what you need to get from this is that the square root of -1 equals I. So anytime you have a negative under your radical and you simplify it, you're going to have an I in your answer. So let's say we've done some work. I'm going to kind of tie in with a little bit what we did yesterday. Let's say you've done the magic and you've worked it out and you get a problem that looks like this under the radical. And from yesterday, I told you to break that down. So -20, the factors to get -20, you could do -1 times 4 times 5. If I multiply these three things together, I'm going to get -20. Does everybody understand? Okay. So this is an I. The square root of -1 always equals I. The square root of 4 is 2. Make sure you put that coefficient in front of the I. This number's prime, so it stays under the radical, and your answer would be written as such. So anytime, I'm going to stress it again, you have a negative under the radical, when you simplify that radical, there needs to be an I in your answer. Does anybody have any questions on that?
Ms. Meyer?
Yes.
Is it like, do you have a -1 in every equation? Like, no matter what, do you just need to have one?
No, it just depends on the answer. If it's a negative under the radical, you'll have a -1.
Oh. Okay.
Only if there's a negative under the radical will there be a negative. Is there a -1?
Okay.
Okay. Now, I'm going to move on to this next part. And I have discovered that we can try to talk theory, and I can try to teach you theory. But what I've discovered in Algebra 2 and math in general, and you guys can tell me if this is fairly accurate or not, I don't think many of you really concern yourselves with the whys and the hows. You just kind of want to know how to do it. I mean, at the end of the day, it's like my Jeep. I go out there and I start it. And when I put the key in or I push my button to start it, I just expect the engine to go. I don't care how it works. I just need it to go. And I feel like that's kind of how we are with math sometimes. So I'm going to explain this to you, and I don't expect you to understand the theory, and I'm not even going to get into the theory. I just need you to do what I'm going to show you to do. Okay. So this next part is called the powers of I. The powers of I. And here's what it comes down to. I need you to kind of memorize these. I mean, I hate to say it just quite so bluntly, but I just do. And the powers of I are in groups of 4. It repeats every 4th term, okay, because it's a pattern. So let me write these down, and I'll show you the pattern real quick. So I to the first power equals I, because anything to the first power equals itself. Okay, anything to the first power equals itself. And I squared equals -1. Okay, it just does. And you're going to hurt your brain really bad if you're trying to go, well, why? Why is that? Just know I squared is -1. I to the third, okay, is -I. And I to the 4th power equals +1. Okay. Again, don't try to rationalize that in your brain. Don't try to understand that. If you're going to plan on taking calculus in a couple years, come see me and I'll explain that to you and break this down for you and show you why. But otherwise, you're going to stroke out in here today probably if you try to figure that out. Now, what I meant by this repeats, okay, it's a repeating pattern, is if I come over here and I do I to the 5th, well, I to the 5th is I. I to the 6th is -1. I to the 7th is -I. And I to the 8th is 1. You see, it's the same. And I can keep doing this for every 4. To make it easier on you, what you should know is that every single multiple of 4, I to the 4th, I'm going to squeeze in. So I to the 4th, I to the 8th, I to the 12th, I to the 16th, I to the 20th, and so on. Every multiple of 4 is 1. Okay, does everybody understand that in here? Okay. Everybody online kind of get that? I'm going to take your silence as you. Oh, yes. Question? Okay, cool. I'm going to take the silence of the rest of you that you understand that. So what I'm going to be asking you to do is to simplify powers of I. To simplify the powers of I. Okay? And what it's going to look like is this. I'm going to move this. Did everybody get it written down? At least the first 4? Okay. What it looks like is this. If I give you I to the 5th, and I say, hey, everybody, what's this simplify into? Okay. You can look at your pattern, but this is how I recommend you do it. Think multiples of 4. Think multiples of 4. How many times does 4 go into 5? 1 time. What's left over? 1. That's I to the first. What's I to the first equal? No, I to the first power. Go back to the original list. Anything to the first power equals what? Itself. So I to the first power equals I. So I to the 5th power is going to equal I. Because I to the 5th power, according to the power of the exponents, can be written this way. I to the 4th times I to the 1st. Everybody remember the rule of the exponents? When you multiply powers with the same base, you add the exponents. Okay. Well, we know from this pattern that I to the first equals 1. So this term right here, this I to the fourth, is actually just a 1. And 1 times I to the first equals I to the first. Don't worry, it takes a little practice. And when we're dealing with these types of problems, it's kind of hard to wrap our mind around it, and I get that. I'm just following state standards. It says I have to teach it. Let me show you with another one. I'll keep the numbers low to start with, and then I'll just show you how the pattern works with any number. I'll let you tell me a number, and I'll show you how it works. So if we went with I to the 13th, for instance. I don't think I like this one. Oh, we're going to do it anyway. How many times will 4 go into 13? 3 times. Okay, what's the remainder? 1. So really what we're looking at is an I to the first, and I to the first power equals I. So what you're doing is you're looking to see how many times 4 will go into that exponent, and then you take whatever the remainder is and then go back to this pattern to see whether it's an I, a -1, a negative I, or a 1. Now, I'm not expecting you to be experts, but does that kind of make sense? Okay, so let me show you how this works. I'm going to get a calculator because I'm going to let you give me a number. Ethan, give me a number between 100 and 500. I don't care what it is. Just give me, and don't make it 100 or 500. Those are too easy.
Okay, 356.
356. Okay, so Ethan says we're going to look at I 3 to the 56. And I want to simplify this. Well, guys, the answer is going to be either I, -1, negative I, or 1. So the question is, how many times will 4 go into this number? Okay, well, I don't expect you to know that off the top of your head. Get your calculator out and see. Go 356 divided by 4. Oh my God, you couldn't. Okay, it goes in 89 times. It goes in, that's fine. It goes in 89 times. You see, because we got a whole number here, there's no decimal. That means 356 is a multiple of 4. If you counted 4, 8, 12, 16, 20, eventually we will hit 356. And what are all multiples of 4? What do they all? That's right, they all equal 1. So 356, I to the 356 power, really just equals 1. So when you put your numbers into the calculator, if you get a whole number like we just did, the answer is 1. Now let's see if we can get one that's not a whole number. Oh, Dylan, you want to throw a number at me? And we'll say between 100 and 1,000, just any. 888. 888. Okay, so you take that calculator, 888 divided by 4, and it's always going to be divided by 4 because this is a pattern of 4, okay? So don't try to get fancy. And look at that, it's a whole number. So I to the 888th power equals 1. Let me try this one more time. Caden. 733. Okay, that is not going to give us a whole number, I can tell. All right, so we're going to try this. 733. So you take that calculator, you divide 733 divided by 4, and we're going to get 183.25. Okay, so we know that that's not going to be a multiple of 4. So what I'm going to do to find that multiple of 4, so I can get my calculator so I can see what the remainder is, so I don't actually have to divide this, I'm going to decrease that number by 1. I'm going to go 732, and I'm going to divide it by 4. And there it is. 732 is the whole number there. So 4 will go into this number 183 times with 1 as the remainder. because I subtracted one. Does everybody understand that? I took one away, so I subtracted one. So 1 is the remainder. So this is really I to the first, which equals I. Okay. Kind of get it? It's not fun. I know that. Look, I put off teaching this since November 1st. That's when we started Unit 4. Okay, but I just want to show you that that's how you simplify these. And if you want more practice, I'll work with you and help you. But that's how I would recommend you do it. And I'm not going to bombard you guys with a bunch of these on any quiz, because I'm going to give a quiz over this next week. I'm not going to give you 1,000 of these, just a couple to show me that you kind of understand. And I'll do smaller numbers just to make sure we understand the concept. But I'm not going to browbeat you with it. I don't see the point. Just remember, it's a repeating pattern. Now, the next part of this is when we start using operations. And if I get through this whole lesson, fine. And if not, like I said, I'll continue it later. What happens when we start multiplying these or dividing these, okay? So let me show you with the multiplication. And remember the rules of the exponents. When you have powers with the same base, you add the exponents. So if I give you this problem, 3i times 4i, you multiply the coefficients just like you would any other number. But then I times I is I squared, because we have to add those exponents. Now, this isn't simplified because you know that I squared equals something else. You have the pattern written down. And before you start the homework and practice, I would write that pattern on your paper so you have it right there. But if you go back to the pattern of 4, that's this, then you can tell me that this is the same thing as this, because I squared equals -1. So 3i times 4i equals -12, and that is why. The good news is the quiz will only be over just this, so it's not like you're going to have to remember a whole bunch of stuff. Let's do this one. -7i times 3i to the third. Well, -7 times 3 is -21. I to the first times I to the third is I to the fourth. But according to the pattern, because it's a multiple of 4, thank you, I to the fourth is 1. So the answer here is -21. And that's what I'd expect to see. Any questions so far? We're up to this point. Other than why do we have to do this? I don't have a good answer for that today. I just don't. I'm tired. Well, let me see what I'm going to ask you to do on the home. Okay. All right. No questions on that part? Okay. The next part I want you to be able to do is simplifying radicals with negatives when there's multiple radicals. So for instance, if I gave you this problem, -4, square root of -4 times the square root of -9. -9. Okay. There's 2 ways you can do this. I want to be very clear about that. You can simplify each radical first and then multiply them together. Or you can multiply these 2 things together, but keep in mind that you're not going to do negative times negative equals positive here. Okay, it's an I squared. So what I actually have here when I multiply, everybody with me, is I'm going to end up with -2i 36 I squared under the radical. I just multiplied them together. Because remember, negative 1 equals what? Negative 1 under the radical is I, right? Okay, so that's where that I squared came from. So that when I go to simplify this radical and get my answer, what's the square root of 36? 6, thank you. And then as far as this exponent goes, just cut it in half and bring the variable out. So 2 divided by 2, that's half, is 1. So I'm just going to bring out 1i. Okay, there's another way to do this that is equally as sucky if you'd like to see it.
Couldn't you just like do how you did, take the negative 1, square root of negative 1 times the positive square root, turn it into like 3i times 2i. Because I got negative 6.
If you did negative 3i times negative 2i, or no, 3i times, you're right. So you did 3i times 2i. Okay, that's going to give you 6i squared. Oh, I see what you're saying. Which, yeah, I see what you're saying. Let me look back at my notes and see how I actually did that. Negative 1 I squared. You are correct. It should have been negative 6i. Excuse me. Just a moment. Yes. Bye. Keegan, guidance wants to see you. So yeah, you're right. It should have been negative. I missed that. And that's the other way I was going to explain how to do that. You can simplify the radicals first. So let me show you this one. Let's do negative 20 and negative 12. Okay, we've been practicing simplifying radicals. We did that yesterday. So I know that this right here simplified is going to be negative 1 times 4 times 5, which is going to give me 2i to the 5th power under the radical. Sorry, not 2i to the 5th power. It's 2i radical 5. And then this is the same as negative 1 times 4 times 3, which is going to give me 2i square root 3. So you multiply these two things together, which gives me 4i squared, and then the square root of 15, which can't simplify any further, and then go back to this. What's I squared equal? Looking at your pattern, negative 1. So it ends up being negative 4 square root 15 as the answer. So the point is you can multiply first and then simplify, or you can simplify first and then multiply. It's not going to matter. Okay. And then the very last thing I'm going to show you, and this will take, because you guys already know how to solve equations, this is where this comes into play when we're dealing with quadratics. If I give you this last thing, if I give you this problem, 4x squared plus 100 equals 0. This is a quadratic. When I solve this equation, I subtract 100 from both sides, and I get 4x squared equals negative 100. Dividing both, because we want to solve for x, so dividing both sides by 4, I get x squared equals negative 25. To solve for x, I have to square root both sides. So x is going to equal plus or minus 5, but there's a negative under the radical, so what has to be in my answer? Not the 1, I. Is that what you meant?
Yeah.
So that would be the answer. Again, whenever you solve an equation that you end up with a negative under the radical, you have to have an I in your answer. Anybody have questions online? Okay, so I went through that last part kind of quick, and I did that on purpose because I want you to be able to start your homework with me sitting here with you, so if you have questions, I can answer them. So the homework's on Canvas. I've got 10 questions for you. Get started on it, and if you have questions, ask so I can further explain or help you, or I can check your answers to see if you're doing it correctly. Do evens. Just do the evens. So 2 through 20, even. Everybody online got that? Well, great. I'm going to keep you online, so as you get started on it, if you have questions, you can ask me.